Hey guys, and welcome to Mr. Castro's class. Today is my first lesson, and we're going to be talking about understanding square roots. Now, this segment is going to be broken up into 4 lessons, and so let's get started with the first lesson, understanding square roots. First, let's look at the core curriculum that is going to be covered. Use square root and cube root symbols to represent solutions to equations of the form x squared equals p and x cubed equals p, where p is a positive rational number. Evaluate square roots of small perfect squares and cube roots of small perfect cubes. Know that square root 2 is irrational. We're going to mostly focus on squares and square roots, but later on down the line, we might touch upon cube roots. So here's some vocabulary that I'll be using today. Let's start with square root, perfect squares, area, principal square root, and inverse operation. Inherently, students are exposed to square roots as early as 3rd and 4th grade. They just don't use the vocabulary. So let's see how we can use geometric figures to increase our understanding of square roots. What is a square root? A number that produces a specified quantity when multiplied by itself. That's from dictionary.com. Now, some of you might be saying, what does that even mean? And if I started going into the math of square roots and I just gave you that definition, most of you would still be confused, and that's okay. So what we're going to do is we're going to break down the word square root. First, we have the first word square, a plane figure with 4 equal straight sides and 4 right angles. And then we have root, source or origin of something. So the next question is, what makes up or is the root of a square? Well, a square's side, which includes the actual measurement, because what is a square if it doesn't have equal sides? So the first exercise that we're going to talk about is with area. And with area, we're going to talk about perfect squares. A number made by squaring a whole number, or in the sense that we're going to be using it, a square with a whole number side lengths. So let's look at a few squares. Can you tell me the area of each of these squares? Pause here after the squares pop up and get the answers, and then unpause to see the answers. Remember that area is equal to side squared, or side times side. The first square, we have 2 units. We have a square with 3 unit side length and a third square with 5 unit side length. If you answered 4 square units for the first square, you were correct. 2 units times 2 units equals 4 square units. If you answered 9 square units for the second square, you're correct with 3 units times 3 units equals 9 square units. And for the third one, if you came up with 25 square units, you're correct because 5 units times 5 units equals 25 square units. Let's look at a couple more. This time, can you tell me the side lengths of the square? Again, pause here until you have your answers. If you answered 4 units for the first square, you're absolutely correct because 4 units times 4 units equals 16 square units. If you answered 6 units for the second square, you're correct again because it's 6 units times 6 units equals 36 square units. And for the last one, we have 8 units. 8 units times 8 units equals 64 square units. Did you know if you were able to determine the side lengths of the previous squares, you actually just completed the task of finding the principal square root. The principal square root is the non-negative square root of a number, of a perfect square. So let's look at how you completed the principal square root for these perfect squares. for the first one, 16 square units. We know that A equals S squared, and in this case, A equals 16, or 4 squared. The square root of 4 squared is actually the inverse operation. Inverse operation is an operation that cancels out another operation. So a square is canceled out by a square root. So the square root of 16 is 4. So the principal square root is positive 4, and the second square root is negative 4. We'll talk about the negatives in the next lesson. In the second square, we had 36 square units. So the area was equal to 36 square units, which is equal to 6 times 6, or the square root of 36, which is 6 units. And for the final one, we have A equals 64 square units, which is equal to 8 squared. The square root of 8 squared is 8 units. Now, let's talk about this phrase, because this is what I teach my students to at least help them understand in the very beginning what a square root is. So square root 49 is written as the following. You can think of it as this. A square with an area of 49 square units has a side length of 7 units long. The square root of 49 equals positive 7 and negative 7. Again, we were only focusing on the principal square root when we're talking about geometric figures. So when you see a square root, try drawing a square and determining the side length of that square. Try these square roots and see if you can find the principal square root. Remember my hint, draw a square with an area of what is inside the square root sign. Remember to hit pause if you want to work on these problems. So now let's look at number 1. Think of a square with an area of 144 square units. The side length of that area would be 12 units. Number 2, think of an area of a square with 100 square units. The side length of that square would be 10. Number 3, square root of 25 is 5. And number 4, the square root of 121 is 11. So I hope that with these examples, you understood at least the basic concept of square roots. In the next lesson, we'll be talking a little bit more in depth with square roots and showing you why there's a negative root with a square root, and also why we can't get the square root of a negative number. If you have any questions or comments, please feel free to email me at hellomistacastro@gmail.com. Please give this video a thumbs up and hit the subscribe button for me. Some of my sources today were dictionary.com, google.com, as well as the tool Google Slides. Thank you again for watching this video. Have a good day.